All right, does the data model growth or decay? And so we're going to look at the output, and we can see that it is going down each time. And so this would be an example of a decay. So when we look at exponential functions, they're normally in the form of a times b to the x. And this b is what's going to determine the decay or the growth. If b is between 0 and 1, then we're going to have decay. If b is greater than 1, then we're going to have growth. So an example of decay could be 1/2 to the x. We can put a number in front, and we're still going to end up having decay if this b value is between 0 and 1. So I could do 0.3. So here are 3 examples of decay. For growth, we just want to make sure that we have a b value that's bigger than 1. So we'll do f of x equals 3 to the x. Uh, 5 times 2 to the x. Doesn't matter as long as this number is bigger than 1. So we could do 2 times 7, 6 to the x. Now the 7, 6 is bigger than 1, so this would be an example of growth. Alright, let f of x equal a log base 3 of x, and we're going to choose true or false for each statement. And so the way this is written, this is our input, this is our output. So when I plug the 1/3 in to the x, we want to see, does that equal -1? So if I do log base 3 of 1/3, and so remember our properties where if this and this have the same base, then whatever this exponent is the answer. And so what we're going to do is we're going to rewrite the 1/3, and so this is going to become log base 3. And so a different way to write 1/3 so that it equals a base 3 is going to be 3 to the -1. And so now we have these being the same, the 3 and 3, and so that means that this output is -1, and so this would be an example of true. Alright, let's look at the next one. Our input's going to be 81, so log base 3 of 81, and so we're going to rewrite the 81 with a base of 3, and 3 to the 4th equals 81. So again, I have the same base, and so this becomes 4, which is what we wanted it to be. So again, this is another true example. Alright, now let's take a look at the next problem. C, log base 3 of 1 to the 27. The same thing, we want to rewrite this with the base of 3. And so 3 to the -3rd. So just to review, when I have a negative exponent, it's going to flip it, and 3 to the 3rd is 27. And so these two things are the same. And so once again, I have the same base. And so my output would be -3. So this is true. So now D, if my base is 3 and my input's 27, three to the third, so they have the same base. So my output here would be 3, which is not negative 3, so this one would be false. Given the expression, circle all of these expressions below that yield the same result when simplified. So the first thing we have to do is we have to figure out what this thing becomes. And so as soon as you see the minus, you want to think of division. And so this becomes log base 3 of 54 divided by 2. And so this becomes log base 3 of 27, which becomes log base 3 of 3 to the third, which becomes 3. It's a lot of 3's. So now we want to simplify this and see if it gives us a 3. So when there's no base, it's the base 10. Okay, so we see the subtraction again, so we're going to divide. So this becomes log of 10,000 divided by 10, which becomes log of 1,000. And so remember, this is a base 10, so we want to figure out 10 to what power equals 1,000. And that's 10 to the third power. So now our bases are the same. And so the output is 3, which is what we have. So we circle this one. Now as we do the next one, notice the negative out front. And so we're going to bring that negative in. And so this becomes 125 to the negative 1. And so with our base of 1/5, so this negative 1 is the same as 1 over 125. And so now we want to rewrite this as with a base of 1/5. And so 1/5 to the third power would give us that 1/125th. And so now my bases are the same. And so my answer is 3. So this one also works. All right, so now as we look at the next one, we're going to work left to right. So as soon as you see the plus sign, you should think multiply. And so 36 times 6 gives us 216 minus log 6 of 1. And a couple different ways you could do this, but one of our special properties was whenever this is a 1, the answer is 0, because if you think about it, if we do our base answer exponent on this one, the log of 6 of 1, we put an x there, and we do base answer exponent. And so this would be 6 to the x is equal to 1, so x would have to be 0. This is just like really minus 0. And so whenever this here is a 1, our answer is 0 each and every time. So now we just have to figure out what this is going to become. So 6 to the third power is 216. So again, we have our answer of 3 because the bases were the same. So this one works. Alright, let's try this one on a different screen. Alright, for this one, since we have the 2 out front, we're going to put it back inside here as the exponent. So this is going to be log base 4 of 2 squared minus log base 4 of 2/3 minus log base 4. And so I'm going to go ahead and write the 16 as a 4 squared. And then over here, the 2 squared, I'm going to write this as a 4. And so now you should notice that these have the same base. And so the exponent here is 1, so this is going to simplify to 1. I can't write 2/3 with a base of 4, so I'm just going to leave it. Here, our exponent's 2. And since they have the same base, simplifies to 2. So now I'm going to combine the 1 minus 2, and so this becomes negative 1 minus log base 4 of 2/3. And this is not going to equal what we wanted. So if we go back up here, we are not circling this one.